Hi everyone, today let's solve the problem game with triangles. So here this was asked in Codeforces round 1000 or 1000 div 2, right? So what the question states here, I insist you to go through the question here so they have you can understand the question. So I'll just summarize the question so that it will be easier to understand, so that we can just write the code in the intuitive way whatever we want, right? So I'll just summarize the question, just try to understand in my way, or explain it in my way so that we understand this one clearly, right? So what the question states here, we are given n points on y equals 0 and m points on y equals 2. So this is, just give me a second here. So this one you can consider y. So this is y equals 0. Yeah, this is y equals 0, and this one you can consider y equals 2, right? So we are given n points on y equals 0. See here, we are having certain points. See this one I'm speaking of, right? They are trying to show the same thing. We are given n points on y equals 0 and m points on y equals 2. Here this y equals 2, we have m points on y equals 2. So in one move, we have to pick three non-collinear points. So let me delete this one. I hope this part is clear. This is nothing but y equals 0 and this is nothing but y equals 2, and we have n points on y equals 0 and m points on y equals 2. And in one move, we have to pick three non-collinear points from a triangle, gain its area and remove those 3 points. See here, when I say non-collinear points, see, non-collinear points means, suppose if we are having 3 points, right? So this can connect here like this, but this should not connect like this in a straight line, right? In a straight line it should not connect 3 points together, right? So that's what they are saying here. So it can connect like this, and the third point has to be in this way, because we have to form the triangle, right? So non collinear means we are connecting these dots in a straight line, three dots. For this particular question they have said three dots. When I say non-collinear means we have to connect 3 points like this. So suppose third point is here, we can form this one uh, triangle by this way, by ignoring this point. So this is just the example I have showed. So that's what that is the meaning of non-collinear, right? So in one move, we have to pick three non-collinear points from all the points, form the triangle, gain its area, and we have to remove those 3 points. First, we have to pick three non-collinear points from y equals 0 and y equals 2, right? And either we can pick the points from this one. Y equals 0 means this one, we have n points, right? Either we can pick from this one and pick this one. We have to pick three non-collinear points, and uh, that form a triangle, and we have to form a triangle out of those 3 points, and we have to gain the area of the triangle that is formed, and then we need to remove those 3 points. Then after forming the triangle, we have to gain the area of the triangle and remove those 3 points, right? So what is our main goal here? Our main goal is to find the k max equals max number of such operations. So k max here, this one they have given max number of operations we need to find. When I say max number of operations, so I'll just give here max number of operations. I'll just give here ops, right? So k max is nothing but kmax is nothing but such how many such operations can be done, means how many within the three dots, from y equals 0 and this one y equals 2, how many such triangles can be formed, and we have to get the area of the triangle and remove those three dots, right? And remove those 3 points. That is nothing but the kmax, that is represented by kmax, and that we need to find, right? And for each k from 1 to kmax, find f of k. F of k is nothing but the maximum total area. Maximum total area means after finding all the triangles accordingly with the input, all the we have to find total max area of this one. Suppose there are three triangles that can be formed from the input. We have to find for this one, what do you call, maximum total area of this triangle plus this triangle plus this triangle that we need to find. This triangle, these three triangles, maximum area of these three triangles we need to find if k such operations are made, right? So for each k, for 1 to k max, we have to find f of k. Again, this f of k is nothing but here k max is how many such triangles can be found within y equals 0 and y equals this one 2. How many such triangles can be found by making use of the three dots that are non-collinear and gain the this one, what do you call, area of the rectangle, and remove those 3 points. How many such triangles can be found? That is nothing but k max, right? F of k is nothing but whatever the triangles that we have found, this one, the maximum total area of those triangles, right? Maximum total area, maximum, I'll just give here maximum area, right? This is maximum total area of such triangles, right? The triangles that are formed, right? So that is nothing but f of k. K max is nothing but how many triangles that can be formed, and f of k is nothing but the maximum total area of the triangles that are formed by considering the input. Let's see the input part later, right? So the triangle's area is base into height by 2. So this is very important. So formula this we need to keep in mind. So triangle's area here, area is given by, so here base into height by 2. Such, just keep this in mind, man, right? So this is the important part. So the triangle's area is base into height by 2. Here height is always 2, height is always 2, right? So just remember this one, area, the formula of the area is base into height by 2, and height, this part we always consider this height as 2, because y equals 2 we have, so height will be quite obviously always 2, right? So area becomes here, area we can represent in this way, absolute of x2 minus x1, absolute of x2 minus x1. Why we are making use of the absolute? We need the solution in this one always in the positive number. We have to represent the solution always in the positive number. Here in this case, that is the reason we are making use of absolute. Absolute is nothing but, suppose if you get the negative number, suppose there is 3 minus 5, right? We get the answer minus 2. So when we make use of the absolute, math.abs or the absolute here, we will get the output as positive in the positive number, right? So we'll get the output as positive, which basically it removes the negative part, right? So we'll get the output in positive numbers. So height is always 2. So area is represented by absolute of x2 minus x1. Just keep this in mind. Area formula is base into height by 2, and height is always considered 2. So we can consider the area as absolute of x2 minus x1, that is x minus difference into 1. This can also be represented by x minus difference into 1. I hope the question part is completely clear, man. First thing that we need to keep in mind here is k max, maximum number of triangles that can be formed, then f of k, total number of this one, maximum area, maximum total area of such triangles that is formed, right? Then we need to find the area, right? So for finding the total area, this is nothing but the maximum total area. How we find the maximum total area? Area formula is base into height by 2. Height will consider always 2. This can also be represented by absolute of x2 minus x1 or x minus difference into 1. That is one thing. I hope the question part is completely clear. Only this thing, right? Only these parts we need to keep in mind. Simple, right? So let me remove this one. Simple, right? I hope the question part is completely clear. Next, what shall we do? Let's discuss the approach followed by the complexities, and then let's write the code, right? First, as usual, let's discuss the approach. So before moving on to the approach, let's do one thing. Let's check the this one, input and the output part. See here, we have been given 5 inputs here, right? 130 0 1 1. So from this, what we need to find? We need to find the k max, means how many triangles can be formed. First thing, and nothing but this one here. So one we have been given here, right? So only one triangle can be formed here, and we need to find this one, f of this thing, right? F of x. When I say f of x, uh, out of one triangle, what is the maximum area of the triangle? That we need to find as well. So those are the two things they have asked us to find in the question, right? So I have said this one multiple times when reading the question. So let's come to the second part here. So this is the input that they have given: 240 100 minus 150 0 50. So we have to get the output 2 150 and this one 200. This 2 is nothing but the number of triangles that can be formed, and this is the area 150, and the 200 is the maximum area, total area of the triangle, particular triangle, right? uh, So this is fine. Same goes with the this one, input 3, input 4, and input 5. See here, we have been given large numbers, so it's better to make use of the long. Either we can make use of the long, or we can just make use of the big integer in Java. If we were making use of the JavaScript, then we would have made use of the big int. That is different thing. But in Java, we can either go with the long or big integer, right? So I hope this part is completely clear. Input and the output part is completely clear. From this input, we have to find uh, how many triangles can be formed non from the three non-collinear points, and after finding such triangles, we need to find its maximum area, right? Total maximum area. So that is 2 for the first one. So same goes with this one, example 2. I mean input 2, same goes with input 3 as well, same goes with input 4, and same goes with input 5, the final one. As we have to deal with the large numbers, let's make use of the long, or this one, big integer in the code. We'll get to know once we write the code. For now, I hope the question part and this one example part is completely clear. They have given us wonderful examples just for the sake of understanding, right? So I hope this part is completely clear. Let's do one thing. Let's discuss the approach quickly, followed by the complexities, and then let's write the code. So here you can clearly see I have considered the same first input that they have given in the example, right? So 1, 3, 0, 0, 1, minus 1. So k max nothing but the output that we need to get here is 1 and 2. K max, the number of triangles that can be formed is 1, and f of x here in this case, it has to be 1. It has to be 2. Means the maximum total area is of that particular triangle is 2, right? So I hope this part is completely clear. We have already discussed this one, right? This is fine. So just keep this in mind. We'll be making use of the two pointers. So we will be going with the two pointers approach, or we'll be making use of the two pointers, right, for this particular problem. So let's move on with the step-by-step explanation here. So this is the input. So don't get confused here. I have written at the side. This is the input. So points we have as this one, y equals 0 and y equals 2. For y equals 0, we have been given 0 here. This is nothing but y equals 0, man. This is nothing but y equals 2, right? So for the point we have y equals 0, we have the 0, and for y equals 2, we have 0, 1, and minus 1. I hope this part is completely clear, right? So we have to choose any three non-collinear points. We have to choose any this one y equals 0 and this one y equals 2. From these 4 points, we have to choose any three non-collinear points. So we can form only one, right? So from this we can just form only one, right? We can choose any three non-collinear points. Means we cannot choose it in a straight line when we say collinear, right? So we need to choose one from y equals 0. Let's choose one from 1 point from this one y equals 0, and 2 points from this one, 2 points from y equals 2. Let's choose 1 point from y equals 0 and 2 points from y equals 2. For example, so this will be 0 comma 0, 0 comma 0, because this one, this is from y equals 0. From y equals 2, this will be minus 1 comma 2 and 1 comma 2. These two we are considering, right? So minus 1 comma 2 and 2 comma 2, because we are considering 2 points from the this one. What do you call? Um, what do you call? 2 points means yeah, we are considering 2 points from y equals 2, right? So total area would be base into height, right? Base into height, in this case it is 1. Base into height, in this case height will be 1. Height is always 2, we know this one, right? Triangle, this one, area equals base into height will be considering. Height is always 2, they have mentioned in the question. In this case we are collecting the max area k times. So what we'll get here, 1. Base into this one is 1. So quite obviously total area would be 2 here in this case. Total area would be 2 into 1. This would be 2 in this case. You can just calculate the area from this points, man, right? Base into height, it will be so we are considering 1 base into 1, right? So this will maximum area would be 2. For this particular one, maximum area would be 2. So let's move on with the next step here. So the number of triangles that could be formed is this one, 1. The points that we got, that we considered, right? 0 comma 0, 1 comma 2, and minus 1 comma 2. So this came from y equals 0 and these two came from this one y equals 2, right? So only one triangle could be formed. So that k max would be 1 and f of 1 here, nothing but the f of x here, in this case f of 1 is 2. So this is nothing but the max area. This is nothing but the max area of the triangle, and this is nothing but the number of triangles that can be formed, right? From the this one, three non-collinear points from y equals 0 and y equals 2. I hope this part is clear. So now we got the k max equals 1 and f of 1 equals 2. 1 and 2 we got as output, which is equivalent to the output that they have given for the first question, first input basically. See here, k max 1 equals 2. In the question, I mean in the example, they have directly given 1 and 2. So that is what k max equals 1 and f of x is equal to 2. So this is how we got the output 1 and 2. So I took the simple input so that we understand this better. I insist you to try with the different input, right? So different inputs. We have four more inputs, totally five inputs. They have given five inputs in the question. I insist you to try out with the second one, third one, fourth one, or the fifth one, so that you understand the question better. So, in my opinion, if you do it, you will understand the question better. That's what I wanted to say, right? So I insist you to try out with the different inputs and derive the solution, right? And try to get the correct solution step by step in what way I have showed you, right? So you just have to find the maximum area accordingly with the first. You need to consider 3 points, three non-collinear points, and you need to find the number of triangles that can be formed. You just have to consider the points and consider the points, non-collinear points from y equals 0 and y equals 2, and you have to find the number of triangles. That these are the first two steps, and the third step is you have to find the total maximum area for the triangle that we have considered. That yeah basically the triangle, for the triangle that we considered, we have to find the this one total area, right? So these three steps are involved in deriving the solution. Finally, you will get the k max as well as the f of x, whether it may be f of 1 accordingly with the this one k max, right? So this is fine. This is how you get the solution. I insist you to try out with the different inputs, right? Again, I'm telling you will understand the question better and you can write the code intuitively, right? So that will be the bigger advantage. So if you I just insist you to try out with the different inputs, man. That's it. So next thing, now we are completely familiar with the approach. Let's discuss the complexities very quickly. So the time complexity would be big O of n log n plus m log m. Why it is big O of n log n plus m log m here? It should have been m plus n, right? So why it is n log n and m plus this one m log m. So here, per test case I'm speaking of. So here one thing is we will be making use of the sorting, so that you will come to know while writing the code. We'll be making use of the sorting, and we are going with the linear scan. So linear scan, quite obviously, it will be plus. So n log n plus m log m it will be, right? N log n plus m log m. So why it is n log n? Again, we will be making use of the sorting. That is the reason. And m log m, n log n plus m log m, it is due to the sorting, right? And we'll be going with the linear scan. This is fine. And the space complexity would be big of n plus m. So why it would be big of n plus m here? So this part, I hope this is completely clear. Time complexity big of n plus m, because we have to store the arrays, and also we will be going with the intermediate lists to find out the difference or for the difference. So we'll be going with the intermediate lists for the difference, and also we'll be storing the arrays, right? So for these two things, total space complexity would be big of n plus m. This part you'll get to know once we write the code. This will be crystal clear, I bet it. So now we are completely familiar with the approach as well as the complexities. Now let's start writing the code. Now let's start writing the code. Initially what we'll do, let's import the input output as well as the util package. So I'll just go with import here, in this case java.io.star. This is fine. And one more thing, this will be import util dot I mean sorry java.util dot star. This is fine. So the next step here is let's go with the main class. So I'll just give here public class any name. I'll just consider main for this. This is fine. So within the main class, so let me give main here. Sorry. So what this took actually, this is not considering here. Why? So let me consider this one. Yeah, this is fine. Just give me a second here. Let me delete this one. Uh, let's make use of the throws input output exception as well here. So otherwise we'll get the error basically. So I'll just make use of input output exception. So this is fine. So let's start writing the code. First thing I would clearly tell you one thing. I want to clearly tell you one thing. We'll be making use of the custom fast input output class. So that will be adding at the last. So I'll just copy paste that one. Let's discuss only the logical part, right? So input output part I'll type, but the last one, this one custom input output class that will be making use of it for the reading inputs and the outputs faster, right? So that we need to read integers as well as we'll be going with the long as well, as we have to deal with the large numbers, right? So you can either make use of the long or the big integer. We'll be making use of the long. You can go with the big integer as well. So here I'll be making use of the this one, what do you call, uh, long in this case. And again we'll be making use of the custom fast input output class that I'll be copy pasting at the end. You can just go through it, pause the video and go through it. Currently I have not um, copy pasted. We'll be doing that one in the future. First let's go with the custom fast input output class. Let's make use of it. So I'll just go with fast input in input output. This one will be new fast input output. This is fine. So the next part is we need to read the number of test cases. In our case we had 5. There are so many number of test cases. In the example they had given 5 test cases, right? So for reading the number of test cases I'll just go with int t equals io dot, this one will be next int. So this is fine. So the next part is we have to store the final input somewhere. So let's make use of the string builder for that. So I'll just go with string builder here. So I'll just go with the variable name sb new string builder. So this part, I hope this part is completely clear. Let's go with the next step. We have to loop over all the test cases because we have to consider all the test cases, right? So I'll just make use of the while loop. So yeah, this has to be greater than 0, quite obviously. So if it is, then let's go with the number of points on y equals 0. We have to consider the number of points accordingly with the input on y equals 0 and y equals 2. So let's try to articulate the same thing in the form of code. This will be int n equals io input output dot next int, this one, right? Same thing goes with the this one as well. When we have to go with the number of points on y equals 2, or we have to consider number of points on y equals 2. So let me copy this one and let me paste it over here, and instead of n we'll go with m, as they have made use of n and m in the question, right? So this is fine. So the next part here is we have to make use of the array to store the x coordinates. Nothing but x coordinates is nothing but on y equals 0, and we have to go with the array, or we have to make use of the array to store the x coordinates at y equals 0 and y equals 2, both, right? So this one, it can consider any number of coordinates, right? So we have to store x coordinates on at y equals 0. N number of this one will be there, n number of coordinates will be there on this one. N number of coordinates might be found on y equals 0, and also m number of coordinates can be found on y equals 2. So that is the reason, as we have already discussed, we will be making use of the long, or you can just make use of the big integer as well, right? So I'll just make use of the long here. So let me write this one in this line itself. So I'll just go with long here. So I hope this part is completely clear, right? So we are dealing with the long integers, so long numbers basically. That is the reason we'll be making use of the long here. So this is fine. Again, this will be long b equals here. This will be new long of m. I hope this part is completely clear. Let's come to the next part. Let's come to the next part here. So we need the input for array A as well as we need the input for array B. So we have to loop through. right? So for that one, I'll just go with for loop here. This one will be int I equals 0, I less than n, this will be I plus plus. So iterated value of the a, I can assign this one to input output dot next int. You would have already guessed this one. Next, not the int, as we have made use of the long, this will be next long. So the number of x coordinates can be n on y equals 0 and m on this one, y equals 2. The integer value can be huge, right? So we have made use of the long here. So same thing goes for the array B as well. The only difference is instead of n here, we'll be making use of m, right? So this is for y equals 2. So let me do one thing. Let me copy paste the same thing and let me delete n, and here let me give m. So this is fine. So let me come out of this one. Let's go with the next step. Here we have to sort the x values on y equals 0, and we have to sort the x values on y equals 2 for pairing as well. While discussing the complexities, we have already discussed this one. The overall time complexity would be n log n plus m log m. It's not n plus m or m plus n. This is n log n plus m log m. We have already discussed this one during the complexities part. We'll be making use of the sorting. Why we have to sort? We have to sort the x values on y equals 0 for the pairing purpose, right? So we need to pair. We can take any number of points. Any number of points means it has to be 3, within 3. We can consider either 1 point or 2 points from y equals 0. Same goes with y equals 2. We cannot consider 3 points in a straight line in y equals 0 or y equals 2. That will be collinear. We cannot consider the collinear points. We have to consider the non-collinear points only. So here in this case, we will be sorting the x values on y equals 0 for pairing, and also we'll be sorting the x values on y equals 2 for pairing. So we can write in this way. I'll just make use of the built-in function here, arrays dot sort this one of a, and let me do one thing, arrays dot sort of this one will be b. I hope this part is completely clear. So the next part, after sorting part, what we'll be doing, let's go with the maximum pairs from A using the 2 pointer, and we'll be going with the maximum pairs from B using the 2 pointers. We can articulate in the form of code in this way. So I can just write here in this way. We'll be making use of the 2 pointers approach. We have discussed this one during the approach, while discussing the approach. So here we'll be making use of the 2 pointers, nothing but length A and length B I'll be considering here. So this is nothing but we are going with the maximum pairs from A using the 2 pointer, and we are going with the maximum pairs from B using the 2 pointers. So I can articulate in this way. So here this will be len A equals n by 2, and in len B, I'll just consider length B or len B here. This will be m by 2. So the next part here is we have to store the max base length from A and B. Quite obviously, we have to store it somewhere, right? So I'll be making use of long here. Yeah, long. This one I would have write here. I would have written here itself. Just give me a second. So I'll make use of long here. This one long. So I'll consider A underscore L. So we are just storing the max base length, right? From the array A. So here, what I'll do. I can write in this way. This will be new long of length A within the array. So let me copy the same thing and make the necessary changes for B. So let me copy paste the same thing here. Instead of A, let me change this one to B, and this one, instead of the length A, this will be length B. I hope this part is completely clear. Let me come out of this one entirely. The next step is we will be going with the maximum base pairs, sorry, from both ends of A. Same thing we'll be doing for the B as well. So we will be going with the max base pairs from both ends of A and B. So again, we need to articulate the same thing in the form of code, right? So for making use of the maximum base pairs, we have to loop through, right? So again, let me make use of the for loop here. This will be int I equals 0, I less than length A, and let me give I plus plus, means we are incrementing here. This one will be A underscore L, nothing, iterated value of A underscore L equals, let's assign this one to A of n minus 1 minus This is fine. Minus hyphen, sorry, hyphen iterated value of the A. Same goes with B as well, right? So we have to consider the maximum base pairs from both ends of B as well. So I'll copy paste the same thing and make the necessary changes here. So let me copy this one and let me paste it over here. This will be int I equals 0. Instead of length A, let make use of length B here. So this remains same. Here instead of A underscore L, let me go with B underscore L. Here this will be B of instead of N, this will be B of M minus 1 minus I. This is fine. And this will be hyphen B of I. So this is fine. Let's move on with the next step here. So after considering the max base pairs from both ends of A, we need the maximum number of full triangles that we can make. So we have to find the maximum number of full triangles that we can make from y equals 0 and y equals 2 non-collinear points, right? So that one, how can we find out? So I'll just go with int uh, kmax we have considered, right? Nothing but kmax, how many number of triangles that can be formed from the non-collinear points from y equals 0 and y equals 2. So I will give we can consider in this way. So this will be math dot min of uh, this will be n plus m by 3. I hope this part is fine. uh, this is the formula basically, math dot min of n comma m. So we know this, right? So in the first example, we have considered the first input in the example. Maximum number of triangle that could be formed in the input one was only one, right? So that was easy. I considered the easy input. So I insist again. I insist you to try out with the different input so you understand the question clearly. It will help you while solving the problem, right? So while writing the code basically. So this is fine. So the next part is we have to output the kmax, right? So in the output we need to show the kmax, so we have to output kmax. So let's make use of, this is nothing but the string builder. Let me go with the append here. Append, we have considered the variable kmax. This is fine. Append. So we have to give the this one the maximum total area as well. So let me do one thing. Let's make use of the slash n here to output the maximum total area in the next line, right? So this is fine. The next part here is, if at least one triangle can be made. If no triangle can be made, that is different thing. That is different edge case. If at least one triangle can be made, we have to track the cumulative area, and we have to consider the point of our a underscore l and b underscore l that we have used. So let's write the simple if condition here. This is nothing but for the this one, if at least one triangle can be made. So this one, k max greater than 0 means if at least one triangle can be made. Here we have to track the cumulative area. If at least one triangle can be formed in the input one, we formed one triangle. We could form only one triangle. Out of that, for that one particular triangle, we have to find the maximum total area, means we have to track the cumulative area. In this case, for that one I'll be making use of the variable sum, and let me initialize this one to the 0. This acts as a counter basically, how many number of such this one, not this one, what's this is for the maximum total area basically, right? Sorry, not the counterpart. So next, let's go with the point of our a underscore l and b underscore l. So this will be, this is 0. This is easy, sorry. This one will be count a equals 0 and int count b equals 0. This part is fine. So then we have to store the what do you call, we have to store the maximum area of the each triangle that's formed with the help of y equals 0 non-collinear points from y equals 0 and y equals 2, right? So that we have to store somewhere. So we'll be making use of the list. I'll just go with list long here in this case. So this will be result and this will be new. Let me go with array list of this one. This is fine. Array list. I hope this part is completely clear. Next, what we'll do, let's make use of the for loop because we have to perform the k max triangle formations, right? So we have to loop through again. So this will be int I equals 1, I less than or equal to k max here, this one I plus plus. This is fine. Within the for loop, what we'll do, we have to ensure the point count A doesn't exceed n minus I, and also we need to ensure pointer count B doesn't exceed m minus I. Along with so let's write these two things. So we have to ensure pointer count A and count B doesn't exceed n minus I and m minus I respectively. First, let's write the code to ensure pointer count this one count A doesn't exceed n minus I. So let's write the simple if condition here. If of this one count A greater than n minus I, then what we need to do, we need we will just prefer b underscore l instead of a underscore l, right? Sum equals sum plus this one b underscore l of count b. This is fine. Let's increment the count b, and let's decrement the count a as we are not considering. So here, and sum will be sum minus a underscore l, nothing but we'll be passing count a in the array. So this part is completely clear. I hope this part is completely clear. Next, what shall we do? So let me do one thing. Let me leave space here so that this looks good. So here, let me copy the same thing. And this, we have ensured that pointer count A doesn't exceed n minus I. Now we have to ensure pointer count B doesn't exceed m minus I as well. So let me copy this one. This one will be count B, and this one instead of n, it will be m minus I, right? So here sum is equal to sum plus, instead of a will consider instead of b will consider a underscore l. Instead of count b, we'll be considering count a. This one will be count, we will increment the count a and will decrement the count b, and sum equals sum minus this one b underscore l of count b. You would have already guessed. So we have copied the same thing and made the necessary changes effectively. So next step, after ensuring the pointer count A and count B doesn't exceed n minus 1 and m minus 1 respectively, so we need to make sure that if only b underscore is available or a underscore is available, to pair now. We have to write for both the conditions, right? So if only b underscore l is available to pair, then we need to write the code for that. Also, we need to write the code for if only a underscore l available to pair currently, right? So this will be two conditions basically. Also, if both are available, that also we have to consider. If a underscore l and b underscore l both are available, then we have to pick the better base, nothing but the triangle with the more area. We need to we need to consider the triangle one, the one with the more area basically, right? So these three conditions we need to write. uh, Two more conditions we have to consider when only a this one a underscore l left, and only b underscore l is left. So basically we need to consider the five cases here. I mean, five conditions we have to write here. So one is for if only b underscore l is available to pair. Second one is if only a underscore available to pair. Third one is if both are available. And fourth one is if only a underscore l is left. And the fifth one is if only b underscore l is left. First, let's start with if only b underscore l is available to pair currently. So if this will be if count a equals n minus I, then what we will do, this will be sum equals sum plus b underscore l. This is fine. So within the array we have to increment the count b. So let me give here count b plus plus. This is fine. So let me come out of this one entirely. Else, if count b equals m minus I, means we will consider only if a underscore is available to pair now. So I can just write here else if count b, this one let's consider count b, this is equal to m minus I, Then within this one, what we'll do, let's give sum equals sum plus a underscore L of count a plus plus. We are incrementing the count a here. So these two conditions from the line number 55 to from the line number this one, what do you call, 61, right? So these two conditions are for these two things. If only b underscore available, b underscore L available to pair, and if only a underscore L available to pair. Now let's write when both a underscore L and b underscore L are available to pair. We have to pick the better base, nothing but the one with the more area, right? So let me consider here, else if, so count a is less than a underscore L, this one dot length, this is fine, and count, this one count b less than b underscore L dot length, this is fine. uh, Within this, what do you call, just give me a second here. If both are available, we have to pick the better base, right? So we have written the else if correctly. So within that, let's write the simple if condition. We have we have four conditions here. So first thing is, if we have to pick the better base, means we have to go with one, we have to go with the one with the more area. So let's go with if a underscore L of count a, this one, if it is greater than b underscore L with count b, so then what we will do, within this if condition, let's go with sum equals sum plus a underscore L of count a. We need to increment the count a, so this is fine. So else, same thing, else what we will do, we can do one thing, else we can just go with sum equals sum plus b underscore L. I would have copied this one, line number 65, and made the necessary changes. This is fine. So this will be, we will increment count b. You would have already guessed this one, right? Count b. So instead of decrementing, it has to, we have to increment the count b basically. This is fine. Let me come out of this one entirely. And if, what if only a underscore left, and what if only b underscore is left? So for that one also we have to write the condition, right? So let's go with the else if. So here this will be count a less than a dot length, count a is less than a dot a underscore L, right? So count a is less than a underscore L dot length. So then what I'll do within this else if, so I'll just go with sum equals sum plus a underscore L. This one, what we need to do, we have to increment the count again, because here only a underscore L is left, right? So this one will be count a, we have to increment this one, this is fine. So we have to write the condition when only b underscore L left. So let me copy the same thing, man, and make the necessary changes. I don't want to type this one again and again. So this one will be, quite obviously you would have guessed, this one count b, if it is less than b underscore L here, uh, this one length, so this is fine. So let me come to the next line. This will be b underscore L of, we have to increment the count b here in this case, right? So this part, I hope this part is completely clear. Let me come out of this one entirely. So the next step here is, we need to result, we need to calculate the maximum total area, right? So first thing we need to calculate, we are successful in calculating, we have already written that code, right? So to calculate the number of triangles that can be formed from y equals 0 and y equals 2. Now apart from after finding the triangle, we have to go with the total area of the triangle, right? So area after I operations, we have written the loop for that one, right? So we need to find the total area after the I operations. For that, I'll be making use of the result dot add. We can make use of the property add. Let's pass the sum here. This part is completely clear. I hope this part is completely clear. Let me do one thing here, so just give me a second. why we have space here. This is fine. So let me come out of this one entirely. So we need to output from f of 1 to f of max. So because we need to consider the maximum total area only out of the triangles that we have considered. We need to consider the maximum one only, right? So we need to consider the maximum total. We need to consider the maximum total area of the triangle, right? So for that, we have to loop through from f of 1 to f of max. We have to consider, right? So we need to loop through. So let's write the simple for loop. I hope this works. Let's see. I don't know if I have made some mistake. So I'll just go with int I equals 0, I less than result dot size. We are considering the size, right? F of 1 to f of max. So this is fine. So let's increment the I. So within this for loop, what we can do, so I'll just go with the string builder. Let's make use of the append. So we need to get the result. So I'll just go with the result dot get of I. So this is fine. So the next step is, let's write the simple if condition here. If I not equal to result dot size, uh, this one minus 1, we'll go with this one string builder dot let me do one thing. This will be append of, this will be, let's leave the space here within the strings. So this is fine. So let me do one thing. This will be string builder dot append. So this one will be slash n. So this is fine. This one will be slash n. So this is fine, because first thing we need to return in the output, we need to return the number of triangles that can be formed, and in the next line we need to return the maximum total area of the triangle that can be formed, right? So these two things we need to return in the output. Kmax is nothing but the number of triangles that can be formed from the non-linear points that we have considered from y equals 0 and y equals 2, and f of x, or in our case in the example we considered f of 1, right? So that is nothing but the f of x, that is nothing but total max area that we have found for the triangle that was formed basically, right? So this is slash n. So let me come out of this one entirely. So this will be, uh, we have to print the entire output at once. So let me go with input output dot, so let's make use of the not this one, print keyword here, and let's pass the string builder. So this is fine. So I hope this part is completely fine. So now we are only left with the this one, what do you call, fast input output utility class. So this one I'll not be typing. This is long basically. This is nothing but the fast input output utility class. So I'll just copy paste this one. We are done with the logic here. So we have successfully, this is the logic for successfully finding the number of triangles that can be formed from the this one y equals 0, that can be formed from non-collinear collinear points that exists on the y equals 0 and y equals 2, right? And after finding that, we have to consider the total maximum area. So we are successful in that. So now we are done with the input output part. So as I have said earlier in the line number, just give me a second, in the line number 6 we will be making use of the fast input output. So I'll just copy paste the fast input output utility class here. So you can just pause the video, you can just pause the video and you can just have a look into it, or you can just type if you are following along with me. So I'll just paste this one entirely. So not this one, sorry, just give me a second here. So yeah, let me do one thing. Let me erase this one. Sorry, what did I do here? So yeah, let me delete this one and let me paste this one, right? So this is for the this is nothing but the fast input output utility class. So you can just pause the video and you can just have a look into it. So yeah, just give me a second. Yeah, this is it. You can just pause the video, and if you're following along with, so along with me, then you can just type this one. You can just pause the video and type, or you can just have a look into it, right? So I can just explain this one if you want. So here within the fast input output utility class, this is nothing but, so this I'm speaking of uh, fast input output, where this one system.n, this line. buffered reader, br, whatever we made use of here. This is nothing but the fast input, and out equals something, out variable we have made use of, right? So this is nothing but the fast output. So within this method, so we have written here string next throws input output exception, right? So within this one, so this is nothing but a string tokenizer we have made use of here, st. So this is nothing but we are tokenizing the next line. Again, I'm telling we are tokenizing the next line, sc. This the line number 105 I'm speaking of, right? So next, whatever we have made use of here, this one int next int and int next long, this part. So this one we are reading the int, and we are reading the long. So we are just reading the integers here, small integers. And we in the question we have already discussed, while discussing I have said by looking at the input we have to deal with the long numbers, right? So we have to deal with the large numbers, sorry, right? Very large numbers basically. That is the reason we'll be making use of the long here, means we are reading the long here, right? So the last part here is void print, whatever I have given here, this part. So in the line number 114 and 115, this and this part, so we are printing the buffered result, nothing but 114 and 115. We have to just flush the output at the end, right? So this is it for the fast input output utility class. So I hope this part is completely clear, and I hope the logic part is completely clear. We have discussed this one multiple times, and I hope the coding part is completely clear. So this is it. Let's do one thing. Let's try with the input. Let's see whether this works or not. I hope this works, man. uh, Let me hit the run button. What we have here, semicolon, expected semicolon, right? Sorry, expected semicolon. Let's come to the line number 7 here. I have given semicolon here. Hey, error semicolon accept expected int. Oh, this has to be equals, not the hyphen. So this is fine. Now let me run this one again. So now we have the error in line number 72 here. Hey, yeah, here I have forgotten semicolon. Let me give the semicolon. In the line number 76 again I have forgotten this one, semicolon. Let me give the semicolon. This is fine. So let me hit the run button again. So let me come to the line number 89. 89 error identifier expected. So what I have to do here, line number 89, 89. So here input output dot int of string builder, right? So what I need to do here, man, 89. So what error? So this is saying, mm, so IO input dot sb, not a statement, not a statement. Identifier expect, not a statement. Oh yeah, this has to be print, not the int, right? Input output dot print of string. We are printing here. So let me do one thing. Let me give print here. So let me run this one again. I hope this works, man. Let's see. Again we have error. So what error we have now? Line number 6 cannot find the symbol. Fast input output. Fast input output. That's what we are. We have considered the class here, right? So line number 6. What error we have? Fast input output equals new fast input output. Mm. Oh yeah, we have to consider the variable here, input output. That itself I have not done. This is fine. So that is the reason we are getting the this one error. Line number 7. Let me run this one. Let's see what error we have. Mm, Cannot find the symbol io dot next int. So we have made use of the input output here. I have now we have successfully made use of the variable io. This is fine. So int t equals io dot next int. Oh yeah, this I has to be capital here. This is fine. So let me run this one again. We have so many errors. Let's see. We have so many typos basically. Line number 11 we have again this has to be capital I. So where is this? So let me make this one capital I, and let me make this one capital I as well. So let me hit the run button here. Hey, exception in thread main Java array index out of bounds exception, index 1 out of bounds for len 1 and main class. So now what we have, let's check the code entirely. So what mistake I have done here is here We are looping through n and m, right? The points we need to consider, right? So this part, so I've done. So what we are considering here, basically, we are going with the input for array A and array B. This one I'm speaking of, the line number 16 and the line number 17. We are considering the input for array A and array B. This one I'm speaking of 16 and 17, right? So here I have copy pasted the same thing, I think. So I changed this one m from n. I didn't change this one. This has to be b of I, not the a of I. I didn't change this one, I think. So that is the reason we are getting the this one array index out of bounds except this one exception, sorry. So let me run this one again. I hope this works at least now. Yeah, now we can clearly see we are getting the desired output 122. So what is the output that we need to get? 122, 150, 200 for the second input. This is fine. For the third input we need to get the output 2 200 I mean 2200. 2200, this is fine. For the fourth one we need to get 499, 198, 260 and 283. So the same thing we are getting, right? So this is fine, right? So this is nothing but here we will be getting the this one, the maximum area we are going with, right? In the second line, two things we are going with, nothing but two triangles, 150 and 200. Two again 1000 and 200. Four triangles can be formed, and this one maximum area is 99. We can consider the maximum area, right? We have to consider the maximum area from that particular triangle. So here four triangles can be formed, and the maximum total area is 99, 198, 260 and 283. Here only two. This is the large number we are getting. Last two numbers, let's consider 00 and 56. 00 and 56. Yeah, this works absolutely correct, right? So let me do one thing. Just give me a second here. Let me copy paste this one signature template here, starter template. So this is fine. Let me copy paste this one entirely and let me paste it over here. So let me hit the submit button. I hope this works, man. Let's see. This has to work. Let's see. Let's wait for some time. You can clearly see here running on test one. Let's wait for some time. So here you can clearly see this got accepted, means yeah, this got accepted, means the code works absolutely correct. See here, whatever the code that we have written works absolutely correct, right? So I hope the coding part is completely clear. The code works absolutely correct in this case, right? So I hope the solution part is completely clear, along with the approach as well as the complexities, right? uh, this is, we have only three steps, man, basically. While articulating in the form of code, that was somewhat difficult. So not difficult, I would say. Finding the triangles, finding, like, considering the this one, what do you call, considering the non-linear points, sorting them, and then finding the number of triangles that can be formed is the easy part, I would say. But after considering the triangle, calculating the maximum area and to display the maximum area, that's somewhat tricky, right? In this question, that's somewhat tricky, right? So these two things we have to this one display, return in the form of output. So the second part is somewhat tricky, I would say. So other than that, the code is not lengthier. I have copy pasted the this one, what do you call, fast input output utility class. Apart from that, you can just go through the three steps. The main three steps is, first thing we have to consider this one, what do you call, non-collinear points from y equals 0 and y equals 2. And then the second step is we have to find the number of triangles that could be formed, that can be formed from the non-collinear points that we have considered, that one. And the third one is, after considering the number of triangles, for each triangle we need to find the maximum total area accordingly with the formula. If you remember, that is base into height by 2, right? So height is always 2 that they have given in the question. So we can consider any one side, right? But we have to go with the maximum total area, right? So we have to go with the maximum total area and we have to return that. So these are the only three steps that we need to consider in this question, right? So if you go step by step, if you break down the problem step by step and try to solve that, this question is completely easier. A bit lengthier, but this is easier to understand. I hope the solution part is completely clear, along with the complexities and the approach. For now, this is it. Thanks for watching, guys.